Very good afternoon and welcome to the session. So my name is Prashant and I'm from HP Enterprise Group, and I'm part of the senior technical member team. And for the past few months, I have been working on this solution called as OBSV App. So what's OBSV App all about? So it's think of OBSV App as a Neutron L2 agent designed for ESXi hypervisors, right? So for any tenant VMs that get hosted or created by an OpenStack cloud and hosted on an ESXi hypervisor, the OBSV app actually does the networking for those tenant VMs using Neutron, right? Prior to OBSV app, there was something called as Nova VC driver, which used to use Nova networks. So the whole idea was to bring in Neutron in picture instead of the Nova networks, and then make use of all the cool stuff that's going around in Neutron, right? So that's how the OBSV app came into the picture. So before I go into the actual problem and what our proposed solution is, I would like to brief upon what the OBSV app is all about for the benefit of those who are not aware of the solution, right? So OBSV app is basically an appliance or a VM, if you will, which gets hosted on ESXi hypervisor, right? So you must all be aware that in a vCenter, in a cluster, there might be n number of hosts. So for each host, we deploy one OBSV app, right? And that OBSV app then talks to the Neutron server, just like OBS L2 agent on a KVM node, right? So the way this whole thing works is we have something called as a Nova proxy compute driver, which is designed to schedule a VM on a vCenter cluster instead of the KVM, right? So what it does is the Nova compute boots a VM or creates a VM on a cluster, and the DRS, that's the distributed resource scheduler of vCenter or VMware, it kicks in and it boots the VM on any given ESXi host within a cluster. So once that does boot the VM, it actually does not connect a NIC to the VM. It just boots a VM without a NIC. The OBSV app agent, in this case, gets notified about the creation of that VM, and then it goes ahead and creates a port group. Now, before I go into that, if you look at the deployment model, this is a reference deployment model that you can see here. So the OBSV app is connected to two DVS, right? One, which we call it as a trunk DVS, which is on the left-hand side, and the other one is basically an uplink DVS. So the trunk DVS does not have any uplink NIC connected to it. It's the trunk DVS on which the tenant VMs are spawned, and all the traffic of the tenant VM is routed through the OBSV app, and then onto the uplink DVS, which is on the right side, and out onto the network. So whenever OBSV app gets a notification that a new VM is created, what it does is it creates a port group on the trunk DVS pertaining to which has the characteristics of the network to which the VM belongs. So it carries the same segmentation ID and same attributes of the network to which the VM belongs. And then it notifies the Nova compute back saying that, hey, I've created the PG. And at that point in time, the Nova compute goes ahead and reconfigures the VM with a NIC and connects it to the PG, right? During the same time, the OBSV app agent, in this case, goes ahead and takes down all the security rules or the security policies for that particular VM and configures its breaches for the traffic to flow through, right? And then the traffic from the VM goes all the way into the OBSV app, and then out of the OBSV app onto the uplink DV switch and onto the network. So just a closer look into how the OVS bridges are configured within the OBSV app VM. We have typically three bridges, the BRSec. This BRSec is the one which connects to the trunk DB switch, right? And this has all the security flows or the open flow rules for the VMs, whatever the security policies are being applied for the VMs. And then we have this integration bridge and the physical bridge. So the integration bridge is just a connect between the BRSec and the data bridge, and the physical bridge is where the actual uplink data NIC is connected, right? So this is a solution which has already been upstreamed in kilo timeframe, It's out there. But what was the challenge? What's the problem now that it's out there? So our customers came back and asked us, how much does it scale? We have a requirement of, let's say, 100 nodes, 200 nodes. We each node having to boot around 30, 40 odd VMs. So can this solution support that kind of a scale, or even more going forward? So we needed to test it out for scale. Now the major challenge with the scale is we need to test out the control path, wherein it's able to communicate with the Neutron server for all the VM create, delete, update events, and the data path. In a sense, all the VMs that gets created, are they able to successfully get an IP address? Are they able to communicate on the data path? Does the routing happen? Et cetera, right? So these were the 2 dimensions of the scale tests we were supposed to do. And the major challenge that we had is no one was going to fund us to buy enough hardware, right? It's not possible to get 100, 200 odd nodes. So how do we test this out? So this was the main challenge that we were facing. So what did we come up with? So what we came up with was something called as a VC simulator, which is there by VMware. So they have this vCenter simulation software, which simulates the ESXi hosts and the VM creation on that hosts, right? So it does that simulation, and it gives you a real-time events, just like a real vCenter does, except for there are no real hosts and no real VMs, right? So that's there. And then we made use of something called a Docker container. I'm sure all of you must be aware of that. So what we did was, so we simulated, let's say, host 1, host 2, host 3, right? We simulated n number of hosts on a vCSIM, and then we took a Ubuntu machine or any bare metal server on which we created these containers. Now each container now represents a ESX host, right? So as I said earlier, we have to deploy an OBSV app on each ESXi host. So in this case, each container will now have the actual OBSV app agent installed on it, right? Which will be corresponding to each simulated host on the VC simulator, right? So what happens in this case is now when the Nova proxy boots the VM, right? It creates a VM onto the vCenter, right? The OBSV app agent, which is hosted on the container, gets the notification to the VMware APIs, right? And then it goes ahead and creates the PG on the vCenter. Everything is virtual in this case, but the OBSV app agent is the real agent, or they're inside the container, right? So it creates the PG onto the vCSIM and notifies the Nova proxy back, and then it reconfigures the VM with the Naik. So everything is simulated. Now this is all the control path, right? How do we simulate the data path now? So what we did was we created another proxy agent within the container, right? So what this does is, this is also kind of reading for the events of the VM create events on the vCenter. The moment it gets a VM created event from the vCenter, it actually goes and spawns a namespace within the container for that particular VM. So in this case, the namespace corresponds to the virtual VM that's out there on the simulated host, right? And what it does is, now again back to a closer look of how the OVS is now structured within the container. So the upper one, the BRVM bridge that we have here, is basically, think of it as the trunk port that we have on the distributed virtual switch, right? And what we do is we connect the namespace to the BRVM, and then we patch the BRVM to the BRSec. That's where the flows are all installed. So when we are connecting the namespace to the BRVM, we are tagging the port, the tap port of the BRVM to the same VLAN ID to which the VM belongs to, or the network to which the VM belongs to, right? In this way, we are now able to create a namespace and simulate the same environment that an actual VM in an actual scenario would do. And then we are now able to communicate, we are able to generate a DHCP request from the namespace. It's able to get the IP address from the DHCP server out there on the network node, and it's able to communicate. So using this way, we have been able to simulate 100 hosts on a single Ubuntu machine with scaling around 3,000 VMs or so. So we have reduced the expenditure of 100 hosts onto a single node, and are able to recreate the environment, and are able to test the control path scale test as well as the data plane test beds. So that's the solution that we have come up with. So any question on the OBSV app or the way we have structured the proxy agent, which actually creates the namespace, you can get in touch with me after this talk. Thank you.